We're going to go ahead and take a look at verifying identities. Verifying identities we're going to do in this chapter and another chapter, but for the most part we're going to hit it hard in this section. There's no fast rule of how to do these. There's just some helpful hints. A lot of times you want to start with the more complicated looking side, or start with the side that has more terms in the denominator. Sometimes the easiest way or the only way that you might be able to see how to do something is to rewrite everything in terms of sines and cosines. Or you may choose to work with the left side, get it worked down to something, and then come back and choose to work with the right side to try to come down to the same thing. But keep in mind, these are not an equation. Yes, they have an equal sign because you're trying to show that the one side equals the other side. But you cannot treat it as an equation. You can't multiply both sides by the same thing. You can't do the same thing to both sides like adding or subtracting. We're trying to show that the one side looks like the other side, so you got to work with each side independently. So we're trying to verify this particular problem right here. Now, there's a couple ways you could do this. Some of you might see one way, some of you might see another way. More likely, how you choose to do it is going to be different than the person sitting right next to you. Well, I'm going to choose to start with the right or left side here. And I'm going to choose to write it all in terms of sines and cosines. So you should remember that secant or cosecant is 1 over sine. Cotangent is cosine over sine. Well, as we look here at the left side, we have fractions here. Well, when you look at the top, which is really a 1 over 1, and the bottom, our common denominator is sine. So let's go ahead and multiply the top by sine and the bottom by sine. So when you go ahead and multiply the top by sine, you're going to just go ahead and get sine. Then you're going to want to multiply the bottom by sine. You're going to take your sine times the first fraction. Well, that side's going to undo the dividing by sine, so we just get 1. And then the sine here times the cosine over sine. The sines drop, leaving you with a cosine. Now, that helps us sum. It simplifies our problem so we don't have fractions within a fraction. But it does not quite yet get us to what we need. Now, we need to try to get to something that is a plus. And in this case, we have a minus. What we want to try to do then is to use our conjugate. Well, we're going to take our problem here. We're going to multiply the top and the bottom by our conjugate of the denominator. Conjugate of the denominator is this. Well, we can only multiply by special forms of 1, so we'll multiply the top and the bottom both by that. You want to go ahead and FOIL out the bottom. 1 times 1. And remember, when you do your conjugates, the inner and the outer drop, and then you do your last terms, a negative times a positive, and so we get this. Now, a 1 minus a cosine squared. You should remember your Pythagorean theorem identities that 1 minus cosine squared means the bottom simplifies down to a sine squared. You'll notice then you have a sine on the top and a sine squared on the bottom. You can cross out your common factor, leaves you with an additional sine on the bottom. Well, we could then write this as 2 separate fractions. 1 over sine plus cosine over sine. 1 over sine is what we're trying to get to of a cosecant plus, and then the cosine over a sine is your cotangent. Now, that's not the only way you could do this problem. Let's take a look at a second way you could have done this problem without turning it into sines and cosines. A lot of times when you have what we are looking at here, basically they're conjugates, but this is on the top because this side here is over 1. This side's on the bottom. So a lot of times when your fraction flips upside down and the sign in between switches, You want to think conjugates. So if we start with the conjugate right away, conjugate at the bottom is this. If we multiply the bottom by that, you got to then multiply the top by that. Well, 1 times the top, that doesn't change it. Multiply the bottom, you're going to get a cosecant squared. Remember the inner and the outer drop. You do your last terms, you get minus a cotangent squared. And then you should say, oh, a cosecant squared minus a cotangent squared. We have a Pythagorean theorem identity that deals with that. Because remember, your basic or Pythagorean theorem identity is that a 1 plus a cotangent squared y is equal to a cosecant squared y. So when you take your cotangent squared to the other side like we have here, your cosecant squared minus your cotangent squared is 1. So the whole denominator simplifies down to 1. So it's really just the top over 1. And that's what we're looking for. Yes, this way here is shorter. But really, I'm not concerned about you finding the shortest, most efficient way. All I want you to do is use correct mathematical steps to show that the one side equals the other side. If you find the shortest way, that's fine. If you find a longer way, that's fine. And your answer is really all your work. That's what I'll be looking at for your answers. So let's take a look at this one here. We could go ahead and start with the more complicated looking side. So let's take a look at the left side. I'm going to choose to start off by turning it into sines and cosines. So we have a cosine over a sine and a sine over a cosine. So then all we have to do is do a common denominator. So cosine over a cosine and a sine over a sine, since your common denominator is a sine cosine. So then that means we get a cosine times cosine, cosine squared, sine times sine, sine squared. We now can take the top, just the top, this part right here, and then we can go ahead and take the top, which we have here, and then instead of dividing by this, which is really over 1, multiply it by the reciprocal, which would be 1 over that. Multiplying fractions together, we're going to multiply the top. 1 times the top's not going to change it. Multiply the bottoms, we're going to get a sine squared, and we're going to get a cosine squared. Now, if we look at what we're trying to get to, we're trying to get to the right side, which is really 2 separate fractions. This fraction here, which is over 1, minus this fraction here, which is over 1. So let's go ahead and take what we have here as one fraction and write it as 2 separate ones. Let's go ahead and take the top of the first part over the denominator. Then we'll go minus, because that's what we have here. And then we'll go our second numerator over your denominator. You now notice here we have cosine squareds top and bottom that drop out. So then that first fraction simplifies to 1 over sine squared. You'll notice on the second one your sine squareds top and bottom are going to drop out. We now have the reciprocal of sine squared, which you should remember is your cosecant squared, minus the reciprocal of your cosine squared, which is your secant squared. And that's what we're trying to get to. Is this the only way to do this problem? No. But it is one way that works.